These are two types of eyeglass frame materials. One is plastic and the other is metal. I have a video about fixing a broken plastic eyeglass frame, where I use a plastic welding method to securely repair the break. As for eyeglasses with metal frame, the repair method is different. Metal frames usually require techniques like soldering or brazing to join the broken parts back together. Some people also use special metal adhesives or tiny screws if the break is at a hinge or a joint. Unlike plastic welding, fixing metal frames often needs higher heat or professional tools to ensure the frame stays strong and aligned. Today, I'll show you how to fix a broken metal eyeglass frame using a simple but effective method. If you find this tutorial helpful, don't forget to like the video, subscribe to my channel, and share it so more people can learn how to repair their glasses at home. First, prepare a spark plug and a pair of pliers. Carefully use the pliers to remove the inner core of the spark plug. Next, use a drill to carefully make a hole in the spark plug. Drill slowly and steadily to avoid cracking the ceramic part. I'm going to create a homemade solution that works like Flux. Its role is to clean the metal surface, remove oxidation, and help the solder flow and stick better, ultimately ensuring a stronger, more reliable joint. Next, I have an old battery here. I'm going to use it as a metal content to enhance the chemical activity of the homemade Flux solution. The metal casing of the battery, usually made from zinc or a zinc alloy, plays an important role in the mixture. When combined with a bit of moisture, it can react to form a mildly alkaline solution. This helps clean the metal surfaces by breaking down oxides, much like commercial flux. As a result, it improves the ability of the solder to flow and bond tightly to the base materials. I'm going to cut the metal casing into small pieces. This increases its surface area, allowing it to react more effectively with the solution, speeding up the process and enhancing the cleaning action for better solder adhesion. Next, I'll add the toilet cleaner into the cup to let it react with the battery casing pieces. When the toilet bowl cleaner mixes with the battery casing pieces, a fizzing and bubbling reaction quickly starts. Tiny bubbles form and rise to the surface, creating a foamy layer while releasing a sharp, slightly metallic odor. The liquid may become cloudy and produce a gentle hissing sound, showing that the chemicals are actively breaking down and forming the flux. I'm going to repurpose the inner core of the battery and turn it into a welding tip, a clever way to give new life to old materials. I extract the inner core from one of these old batteries. This core is usually made from conductive metal, and its size makes it perfect for precise soldering tasks. I'll grind the battery core to shape it into a fine welding tip. This will help it heat up evenly and work more precisely. Now that it's been ground to the right shape, the core fits snugly into the spark plug. And just like that, we've turned it into a working welding tip. I need to secure the lens in place first, so it stays steady while I do the plastic welding later. This will prevent any movement and ensure the frame lines up correctly for a clean, strong repair. Now, let's move on to the electrical wire part of the process. I'll prepare a suitable wire, strip off the insulation at the ends, and get it ready for connecting and welding. This wire will help conduct heat and create a strong bond for the metal frame repair. You can adjust the temperature yourself by changing the wiring or adding a resistor. It's super flexible for small welding tasks. Since this is a mini welding machine, thick electrical wires aren't necessary. I'll use this type of wire, and it will work just fine. The key is to secure the connections and properly insulate the contact points to prevent electrical leakage. To complete the wiring, I'll attach an alligator clip to the other end. It makes the connection quick, secure, and easy to detach when needed. I'll also use a clip to create a handy handle for the welding tip and to securely hold the spark plug in place. Next, I'll thread the electrical wire through the spark plug and then insert the battery core inside. Then, I'll wrap electrical tape around the spark plug and the wire to secure them tightly in place. The tape will keep everything stable, prevent the wire from slipping, and provide some insulation for safer handling while welding. For this wire, I'll attach alligator clips to both ends. That way, it's easy to connect and disconnect from both the power source and the device. I also need to make a grinding tool to smooth out the solder joint on the eyeglass frame later. This tool will help polish and level the surface, giving the repaired area a cleaner, more professional finish. Once the welding is complete, let the flux mixture sit for about 1 full day so the reaction can fully complete. After 1 day, the battery casing is completely dissolved, leaving behind a fully reactive flux solution that's ready to use for soldering the metal frame. For the power source, I'll be using a standard motorcycle battery. It's a 12V lead-acid battery, powerful enough to heat up the welding tip and stable for small electronics work. This type of battery is easy to find, rechargeable, and delivers consistent current, which makes it perfect for our DIY welding project. Now it's time to put our DIY soldering tool to the test. I'll begin by trying to weld onto this razor blade. After soldering the 2 razor blades together, the joint feels surprisingly strong. Even when applying pressure or flexing slightly, the blades stay firmly connected without any signs of separation. This is bonded well to the thin metal surfaces, creating a solid bridge between them. After testing the soldering setup to make sure it works properly, I'll now solder the 2 broken parts of the eyeglass frame together. Carefully align the pieces, apply heat, and let the solder flow to create a strong, secure bond between the metal parts. When I apply the solder to the broken area, it starts to melt and flow smoothly along the joint. But to make it even stronger, I'll apply a small amount of solder on top to further reinforce and secure the joint. And to make sure the solder sticks firmly to the metal frame, I'll apply a thin layer of flux over the joint before heating. The flux helps clean the metal surface, prevents oxidation, and allows the solder to flow smoothly, creating a stronger and more reliable bond. After applying the flux, the solder appears shiny and slightly wet, spreading more easily along the joint. The flux creates a thin, glossy coating on the metal surface, which helps the solder adhere tightly and fill any gaps, ensuring a smooth and strong connection once it cools. This extra layer ensures the 2 parts stay firmly connected and adds durability to the repair, preventing the frame from breaking again easily. After applying the solder, it flows into the joint, filling any tiny gaps and forming a smooth, shiny layer over the broken area. The bond becomes solid and strong, giving the eyeglass frame stability and a neat, finished appearance. After that, I'll use the grinding tool I prepared earlier to polish the soldered area. This helps to smooth out any rough spots, remove small imperfections, and give the repaired section a clean, finished look that blends well with the rest of the frame. After completing the repair, the eyeglass frame is fully restored, and the broken joint is now solid and durable. The soldered area has been carefully smoothed and polished, so it blends seamlessly with the rest of the frame, giving a clean, professional look. While metal frames benefit from soldering and a properly prepared flux, taking the time to align, secure, and polish the joints ensures a strong, durable, and neat repair. If you found this guide helpful, don't forget to like the video, subscribe to my channel, and share it so others can also learn how to repair their glasses safely and efficiently at home.